Please welcome President and Chief Executive Officer of Worldview, Ryan Hartman.
Worldview exists to inspire, create, and explore new perspectives for a radically improved future. I know that's very aspirational, and so it's my job here today to make that real. So right now above us, high in the atmosphere, is the stratosphere. It's an operable domain. Most of human history has largely ignored the stratosphere, too high for aircraft to loiter, too low for satellites to orbit. Just an atmospheric layer that you learn about in school, not well enough understood to operationalize. Worldview exists to change that. We build stratospheric platforms that can stay over an area for a very long period of time, 30 days, 60 days, or more. We do this by leveraging four-directional winds that exist in the stratosphere. And by controlling our altitude with ballasted air, we can freely navigate in the stratosphere. And we can do what we call station keeping. It's simple in principle, but complex in execution because you're steering a month-long mission using the physics of the atmosphere. Navigation becomes a vertical decision that creates a horizontal result. Stratospheric sensing delivers imagery that is higher resolution than any satellite with much longer endurance than UAVs. UAVs can get close and they're precise, but their endurance is limited to hours. Satellites can be global and predictable, but they also have fixed orbits and limited revisits. I'm happy to report that the stratosphere is now open for business. For our customers, this isn't a debate about which domain wins. It's about getting the predictability of a satellite, the precision of a UAV, and the enduring presence of a stratospheric platform, all stitched together in one operational picture. Because when minutes matter, data isn't the product, decisions are. And here's the core idea I want you to take away from us today. The stratosphere is operational, and AI-driven workflows built on Palantir are how we scale it. Let me show you why that matters, beginning with a hard constraint we used to accept. Previously, from initial flight plan to launch, it can take us no less than 2 weeks. 2 weeks works for a scientific payload, but 2 weeks is unacceptable for an operational demand that shifts by the hour. So our first focus with Palantir was simple: compress time without compromising safety, compliance, or mission objectives. And that's where our journey with Palantir began. In January, we partnered with Palantir. In a very short period of time, we delivered AI Flight Director powered by Palantir Maze Mission Planning. Here's what that means. So a stratospheric mission isn't a point-to-point flight. It's a multi-week, sometimes multi-month operation conducted at the edge of Earth's atmosphere, riding winds that don't care about our schedule. Our customers obviously do care. They care about exact mission criteria, things like coordinates, dwell time, sensor coverage, and the ability to adapt when the world changes. So we use AI Flight Director to simulate optimal trajectories that meet customer objectives while operating in a dynamic, sometimes unpredictable environment. And we do it in a way operators can trust. They can audit it, and then they can execute it. Now the second piece with Palantir. Planning is only half of the battle. I'll tell you, the real fight is disruption, a sudden SIGMET, a storm cell that accelerates, a wind shift that turns a safe trajectory into a risk, or an intelligence briefing, and the AOI has shifted based on new intelligence. Systems must be immediately retasked to transit to the new location, and historically, that becomes a scramble using spreadsheets, computer modeling, phone calls, manual replans, and time that you just do not have. With Palantir, we connect live telemetry from the balloon's sensors and combine that with live meteorological streams and operational constraints. And then we make the operation AI aware in real time. So instead of an operator hunting for the right data, Maze Mission Planning Agent surfaces the alert, it contextualizes it, and proposes a set of actions. Approve a reroute that an AI Flight Director already modeled. Adjust to catch a different wind band. Update a constraint and see downstream effects instantaneously. And this is where the stratosphere ceases being a platform that collects data and starts becoming a platform that participates in decisions. And the outcome isn't just speed, it's safety and predictability at scale. At the end of every flight, we take what happened, we take what we learned, all the things that we decided and what resulted, and we write it back. And with that, every mission, the ontology becomes a living memory of the operation. Past events, decisions, and outcomes, enriching every future flight plan and execution. And so that's what we've built so far, AI Flight Director that compresses time and makes execution adaptive. Now let's talk about what happens next, because this is the part that changes the economics. It's easy to celebrate a single launch, but the scaling story is completely different. Palantir-powered workflows don't just make one launch faster, they make dozens or 100 simultaneous launches possible with the same operational efficiency. What they do is operationalize a swarm. And a swarm is not a marketing term, it's a control problem. When you have many assets in flight, you need fleet orchestration, automated deconfliction, dynamic retasking, and prioritized attention so humans are focused where judgment is required. And we can now see the path to that system. Imagine this, multiple stratospheric platforms in flight, each streaming sensor data, each running edge inference, each capable of being retasked in minutes. A potential object of interest appears, the platform detects it, the system distills it, and an AI agent contextualizes it. The operator gets a recommendation with the rationale, and the action is executed. And that's the future of in situ decision making. And it matters because it changes what's strategically possible. We had a roadmap to get there in 2030, and we can now see that possible in 2026. And that's why we're partnering with Ondas. This partnership immediately creates a multi-domain ISR alliance and a suite of offerings that combine worldview stratospheric balloon systems with Ondas' expansive portfolio of unmanned systems. This partnership accelerates something we already believe, that the future is multi-domain, executed as one coordinated system. And so here's what changes. The same Palantir native workflows that plan and operate stratolites become the backbone for orchestrating multiple domains, stratospheric platforms, UAVs in groups 1, 2, and 3, and space-based assets. Today, across the industry, systems have always had their own walled garden. Separate data feeds, separate tools, separate teams, separate timelines, and customers end up patching together fragments just to infer what's happening. And we're building a system of systems, unified intelligence, with a single pane of glass. One operational picture, one workflow language, one set of decision loops that can task the right asset for the right moment. And if you want persistence, the stratosphere holds the station. If you want precision, a UAV gets it done. If you want global context, space completes the frame. The operator shouldn't have to care which domain the data came from. They should care whether that the right decision is made fastest and it's accountable. Let me close where I started. We exist to inspire, create, and explore new perspectives for a radically improved future. That future requires persistent awareness, resilient economics, and decision advantage. Battles are won with power. Wars are won with economics. Stratospheric platforms are low-cost, persistent, hard to counter without expensive, specialized systems. With Palantir, we turn that persistence into operational tempo. With Ondas, we expand that tempo across all domains. The stratosphere is open for business.